So hi all, welcome to JS Academy. So in the previous class we have discussed about the problems related to slip and slip speed and rotor speed. So in this class we will discuss about the problems regarding rotor parameters, right? So if you have any doubts about these formulas, already these classes has been placed in the playlist, so you can go through that classes. Okay. So here the problem is a 3-phase 50 Hz induction motor. A 3-phase 50 Hz induction motor has 6 poles and operates with a slip of 960 rpm, right, at a certain load. Determine the frequency of rotor current. So first of all we will write given data. So given data in this, frequency is equal to 50 hertz. So frequency 50 hertz and poles equal to 6, okay, and slip rotor speed, right, nr is equal to 960 rpm, okay. So now determine the frequency of rotor current. Here in this sum it is not asking what is the value of rotor current, okay, it is just asking there is a rotor current and what is its frequency. That means we have to find out rotor frequency. We have to study the question clearly, okay. So now what we have to find out, okay, we have to find out what is the frequency of rotor, okay, we have to find out what is the frequency of that means rotor frequency we have to find out. So what is the formula for rotor frequency? Fr is equal to S into F, right? Fr is equal to S into F. So here our main target is to find out what is slip. So we already know what is the formula for slip. S is equal to Ns minus Nr by Ns, okay. So Ns is equal to 120 F by P. Ns is equal to 120 F by P. So 120 into 50 by poles, nothing but 6. So this 20 times and it is 1000 rpm, okay. So Ns is equal to 1000 rpm. So we got Ns is equal to 1000 rpm. Now what is the value of slip? Slip is equal to, so now what is the value of slip? Slip equal to, what is the stator speed? Ns is equal to 1000 minus what is the rotor speed? 960 by Ns, 1000, okay. So 40 by 1000. So here we get the value. So here, so 425 times, so 1 by 25. So slip will be approximately, slip is equal to 0.04. This is the value of slip. This is the value of slip. Now our main concept is to find out what is rotor frequency. So what is the frequency of rotor? Fr is equal to S into F. What is the value of slip? S equal to 0.04. What is the fundamental frequency? F is equal to 50 Hz. So Fr equal to some 0.04 into 50, right. So 0.04 into 50 is nothing but it will be approximately, this 0 and this 0 gets cancelled, and 5 4s are 20 and 2.0. That means Fr is equal to 2 Hz. So Fr is equal to 2 Hz. So this is the frequency. This is the frequency of rotor. This is the frequency of rotor current, okay. This is the procedure to find out the value of rotor frequency. What is the rotor frequency? It is nothing but 2 Hz, okay. I think you understood the concept clearly. So going to the next problem. So the next problem is, you can clearly look at here. So an 8-pole 3-phase 50 Hz induction motor is running at full load with a slip of 5%. What is the slip? It is 5%. The rotor is star connected and its per phase resistance and standstill reactance are 0.35 ohms and 2 ohms respectively. The EMF between the slip ring is 150 volts. Determine the rotor current per phase and the rotor power factor, assuming the slip rings are short circuited, okay. So in the same concept in the previous problem, so what we have to do, we have to write out, we have to first define what is the given data, okay. We have to define first what is given data. So coming to the given data, what is the given data? So if you look at this, so what are the number of poles? P equal to 8 poles. And what is the frequency? Frequency equal to 50 Hz, right. So what is the slip? Slip equal to 5%. That means 5 by 100 and the value will be 0.05. So slip is 0.05. the rotor is star connected. So this is the most important concept that has to be considered in this problem. It is star connected, right? So the resistance and reactance are, so what is the value of resistance? R2 is equal to 0.35 ohms and X2 is equal to 2 ohms. Okay. So the next, the EMF between slip rings, that means E2 is given as 150 volts. So E2, if you look at here, the EMF between slip rings, so it is nothing but 2 slip rings, that means line to line voltage. What is it? Line to line voltage. So line to line voltage. But coming to the problems we are solving, we are always interested in finding out the per phase voltage. That means you can clearly understand. So this voltage is nothing but it is given in the form of star. So this is star. So star E2L, right? This is the line voltage, okay, 150 volts. So what is our target to find out? So what is our target to find out? What is the rotor current I2R and what is the rotor power factor cos phi to R? So both these values we have to find out. So if you go and clearly observe here, okay, so what is cos phi to R and what is I to R? So now first of all we have to convert this star. So we are always interested in finding out the per phase voltage. So what is per phase voltage in star connection? So I will change the color. So in star connection, already we know what is the formula for in star connection. So VL is equal to root 3. So VL is equal to root 3 V phase. So apply this same formula here. So what is VL? VL is nothing but 150 volts. So what is the phase voltage? V phase is equal to VL by root 3. So what is the line voltage? It is 150 volts and divided by root 3. So the value will be approximately equal to, I have already done it by using a calculator. So you also can follow the same procedure to find out V phase. So V phase is equal to, it will be approximately 86.60 volts. So what is the per phase voltage? I mean per phase or so just a second, we can write it as E2 EL and E2 per phase. Okay. So this will be E phase. Okay, E phase is equal to EL. So what is that? So E2 per phase is equal to 86.60 volts. So this is the per phase voltage of rotor current. This is the per phase voltage. Now our target is to find out what is current. So let us draw a boundary here. Yeah, 1 second. Yeah, let's move. So now our target is to find I2R. What is the formula of I2R? It is nothing but E2R by Z2R. So rotor current. So our target is to find out what is rotor current. So I2R equal to E2R by Z2R. So what is the formula for E2R? S into E2. We already derived this formula, and Z2R is nothing but square root of R2 square plus SX2 whole square. So what is S? So slip is given as 0.05 and what is the E2 phase? 86.60 and what is the value of resistance? This is nothing but 0.35 whole square plus what is the value of slip? 0.05 and what is the value of reactance? X2, it is nothing but 2. So both these we have to square and we have to find out the square root. So now dividing both these values we will get what is the value? So I2R is equal to, so if we solve this particular calculation in the calculator, we will get so I2R by Z2R is approximately equal to this will be the value approximately 4.33 by what is the value of Z2R? It is nothing but 0.364. So I2R value will be so 11.89 amperes. So what will be the value of so current? So I2R is equal to 11.89 amperes. So 11.89 amperes. So we can take this value as 11.89. So we can take this value as 11.89 amperes. So this is the procedure to find out the current. Here we can find out it Z2R is nothing but this is Z2R, right? This is S into E2. So Z2R value is 0.364 because I will use this value in rotor power factor. Now coming to the next formula. So next concept or next parameter, it's nothing but rotor power factor. So rotor power factor is denoted by cos. So one second. Yeah. So cos phi 2 R. So cos phi 2 R, what is the formula for power factor? R2 by Z2 R. So R2 R. What is the value of resistance? We already know the resistance value is nothing but 0.35. And what is the value of Z2 R? It's nothing but 0.364. Now dividing these two values, so from calci we get the value approximately equal to 0.96. So what is the value of cos phi 2R? It will be 0.96. So this is the procedure to find out the power factor and rotor current. So now if you go to the problem, so what is the value of rotor current, right? So what is the value of rotor current? What is the value of rotor current? The current value is nothing but 11.89 amperes. This is the value of current. Okay, this is the value of current. Now what is the power factor value? So 0.96. So 0.96. So this is the procedure to find out the values. I think you clearly understood the problem. So if you have any doubts, you can comment in the comment box. So these are the two problems related. In the next session, I will solve another two problems related to these rotor parameters. So these are very easy questions and we can easily solve by knowing the fundamental formulas. Okay. If you like this video, please like, share and subscribe. Okay. Thank you.